Hey math kids, today we're going to talk about problem solving by integration. Alright, so we're given this function written in red, and it is the rate of power consumption by the city of Bristol, and we're looking at it over the course of one day. And 0 is midnight, and 24 is the next midnight. And so 1 would be 1 a.m., 10 would be 10 a.m., etc. Now they want us to evaluate this from 0 to 12, take the integral, and so right here is just the integral without my plus c, because we're going to be using this. Let's see, let me zoom out a little bit. Okay, so we're going to be using this because that's the antiderivative. So let me just kind of walk through it a little bit. So sine gives us negative cosine, so that's why this negative sign showed up. Rewrote the 0.3, rewrote the inside, and then if I was to distribute this pi twelfths to the t and to the 10 would just be a constant, so that would go away for my derivative, and then but pi twelfths t would give me a derivative of pi twelfths, but then we multiply by the reciprocal because we're taking an antiderivative. Okay, so that's what that is. And then cosine turns into sine. I still have my 0.1. It's still positive. And for similar reasoning, I have to times this by 6 over pi because I'm dividing by the derivative of the inside. And then my 0.775 just gains a t on the end. Now, if I want to evaluate this at 12 and 0, I just need to plug in a 12, see what I get, and then plug in a 0 and see what I get. Now, when I do that, I'm going to simplify this just a little bit. So I get, I get negative 0.3 cosine. And if I plug in a 12, 12 minus, I'm going to do some of the simplification on the fly because I just don't want to write a ton of stuff. So 12 minus that, so that's going to give me just a 2, and then a 2 over 12 will turn the bottom into a 6. So this ends up just being pi 6. And then on the outside, I still have 12 over pi. Okay. And then right here, I have plus 0.1 sine, and if I plug in the 12 here, 12 minus 6 is 6. 6 over 6 cancels, so I get sine pi, and then 6 over pi is still there, plus 0.775 times 12. So that's just when I plugged in 12. So that's what this thing is. Okay? Now, a couple things that, oh, well, here, I'll do 0 as well. Let's do that in yellow. Okay, so if I plug in 0 for this one, I get, let me see, let me write it like this, minus this. And so if I plug in 0, I'm going to get negative 0.3 cosine, and then 0 minus that, so it's just negative 10 over 12, so it's negative 5/6 pi, and then that's times by 12 pi on the outside, and then we add that to 0.1 sine, and if I keep going, plug in a 0 there, the 6's cancel, so that's just negative pi, and then 6 over pi. And then if I times this by 0, it just goes away. Okay, so we can just throw all of that into a calculator, and if we do that, a couple things happen. For example, if I'm looking at sine, if I look at pi, or if I look at negative pi, both of those go to 0, so this entire portion's gone. This entire portion, including all the stuff over there, is gone, just because that all goes to 0. And so if I just plug in the remaining parts and simplify it, the answer to this ends up being, I'm not going to go through it because I feel confident that you guys can plug that in. And that's gigawatt hours. Okay? All right. Now they're going to ask us to do something similar. 12 to 24 E of t dt. So once again, we plug in 12, so we see that we get exactly the same thing here, but then we also plug in 24. And so plugging in the 24, it's going to look like negative 0.3 cosine. If we plug in 24, 24 minus 10 is 14, and then that's going to be 7/6 pi. And we still have that. Okay, and then sine, plug in a 24 minus 6 is 18, so that's just going to be 3 pi. Plus 0.775 times 24. Okay, since 24 is on top and 12 is on bottom, we would take our answer from this after plugging it into a calculator and then subtract our answer from this. And if we do that correctly, we end up getting 11.285 gigawatt hours. Okay, and then finally, they ask us for this integral. I'm trying to get, we'll go up here. So the integral of E of t from 0 to 24. And so all we need to do is take 0 to 12 and add it to 12 to 24. And if we add those together, we end up with 18.6 gigawatt hours. Just adding these two numbers together. Okay, I know I skipped through a lot of the simplification on that. It's just really tedious. Feel free to use a calculator, or you should use a calculator. If you need help with that specifically, I'm happy to help you in Math Lab, or if you have other questions, come to Math Lab. Until then, calculator.